So my name is Matthew Ballance. Professionally, I work at Mentor, Siemens Business, as a product engineer. And nights and weekends and whenever I want to think about it, I work on a variety of open source projects. And one of these is an open source plugin for the Eclipse environment for editing Verilog and SystemVerilog files. And that's what I'm here to talk about. So in the agenda today, we'll talk a little bit about integrated development environments, what they're for, how they're a little bit different than just editing text files, and then some of the key features of two projects, DVKit and SVEditor. So moving on. So all of us, as we develop both software and hardware, deal with a lot of different files in the projects that we work on. Projects have hundreds or thousands of individual files of many, many different types, whether that's Verilog and SystemVerilog, Python, Perl, Makefile, script, C++, etc. Now, even as individuals, speaking for myself, when I come back to a project that it's been a while that I've worked on, it takes me a while to kind of get back into where do the files live, where's the content that I want to work with. And if you're thinking of having someone new working on a project, whether that's commercially or open source, that's also a challenge to make that project accessible to that new person, make it easy and productive for them to get started working with the code in that project. Now, IDEs, integrated development environments, can be a very powerful way to make projects more accessible to people, to make it easier for people to navigate around sometimes in unfamiliar content. So the biggest difference between an IDE and an individual text file is text editors generally work with a single file at a time. There are some nuances. There's a little bit of difference sometimes. Sometimes Emacs, for example, will let you, do some indexing across the files. But generally speaking, you have a single file open at a time. You can look inside that file, but that's it. An integrated development environment works with a whole project of files at a given time. So you can look across the content within that project, across all the files, search for content, navigate across various content. It makes you much more productive. It gives you much easier access to the content that you're working with. IDEs are often very extensible, and there's a variety of integrated development environments out there, and most of them are fully extensible for different languages, different capabilities, and this can also make them very powerful as a way to enable people to do things that maybe the original developer didn't think of when developing the tool. So generally speaking, I'm finding that integrated development environments are fairly well used in the software space. So, Visual Studio from Microsoft for C++, there are tools on the Android side as well. On the hardware side, generally what I'm finding, there are some exceptions, but I'm finding this is a little bit of a foreign concept, unfortunately, I think. So how did I come to this project? Well, back in 2008, I took on a new role at my employer that required me to learn SystemVerilog. Previously, I had been working almost exclusively with C++ and Java, and had gotten very used to, after a learning curve, the benefits of what an integrated development environment could do for my development process. So when it was time to learn SystemVerilog, I started looking around. Okay, where's my SystemVerilog plugin with the syntax for SystemVerilog? And there was none at the time. And so I thought, okay, well, if I could at least do some syntax coloring, that would be a big step forward. And so I did that, and not too long after that, I thought, well, maybe if I could, at least find some things around the files, show some structure, and, basically it went on from that point to I'll show some of the features of this plugin today. The development of DVKit, the other program I'll talk about, was sort of a similar thing. I found myself spending a lot of time customizing my Eclipse installations. I had generally between half a dozen and a dozen different plugins that needed to go in, and every time I got a new machine or went to a new environment, I had to go through this process of plugging everything in. I thought, why am I wasting my time on this? Why don't I set this up so that myself and other people can just have a ready-made package? So DVKit is that ready-made package. It's an Eclipse-based integrated development environment that you can download. It has Windows installers, OS X installers. You can download it for Linux and just unzip it. And it has a whole variety of plugins provided right with it. You can edit C and C++, you can edit Markdown files, Perl, Python, pretty much any file, in my experience, that you might come across. Shell scripts, SystemVerilog. While developing hardware or software, you can edit with the built-in plugins. Even if you're editing Chisel, I don't ship a Scala plugin, but there is one that you can add in if you want to add that in for Chisel. So I'll spend a little bit of time going over the key features of the Verilog side of things. This is the features that are there that help you navigate and create content for SystemVerilog and Verilog files. These features are fairly common when it comes to the other language support plugins as well. The first set of features really is around navigation. As I mentioned, you have lots and lots of files, lots of content in different places, and you need to make sense of it. You need to figure out where things are. The language-aware content navigation is pretty simple. In Eclipse, you generally point to a type and you just activate the open declaration. There's a menu pick for that, there's a hotkey for that, and it magically just takes you over to opens the source file, navigates you to where that element is declared. That's generally the replacement for grep, but much more powerful. Now, Eclipse itself actually provides just some base search and navigation functionality, and this works across all files. And initially, this might not actually seem that useful, but in my experience, it's actually very, very powerful. So oftentimes I know the file I want to open has a name that looks kind of like this. It ends with this, it starts with this, it has this in the middle. This is the type of thing I would generally go to the shell and do a find and kind of look around and find the files. Eclipse, for all files in the project, has this browser you can open up and just say, here's the pattern I want to find, and it lists all the files that match that pattern. You can just browse through and open the one that you want. So this can actually save a lot of time in terms of context switching, having to go over to the shell, find the file you want, etc. Eclipse, for all files, has a similar capability for searching content within files. This is the type of thing you might do with grep. But from my experience, the way that Eclipse shows the results here, shows it hierarchically, where the files exist in the file tree. This is actually much more useful, much easier to navigate than grep. And again, it sort of keeps, this is kind of a theme with integrated development environments, it keeps you in the same context. So you're not switching around, jumping around to do the different operations that you need to do. Now, back to the Verilog side, the SystemVerilog side, another element of navigation really has to do with documentation. Now, a certain set of Verilog and SystemVerilog is documented with natural docs markup. This is kind of a language-independent format of documentation. And the SV Editor plugin recognizes these comment tags on content. And so if you hover over an element that is documented with a natural docs tag, it will pop up inline in a hover the documentation. So this, again, is a pretty handy thing. You're wondering what that UVM element is. UVM happens to be a library documented with natural docs. You hover over the element, it pops up the documentation for you, describes exactly what you're looking at. So if you like to document your designs this way, you can also very easily see how those elements are documented. Now, navigation is important, but content creation is also an area where integrated development environments can help you out. Code templates are kind of a generic way of laying out repeatable content. And Eclipse and the SV Editor plugin provide some help here. So basically the way this works is as you're typing, you hit the content assist key, which is a control space in Eclipse, and it will prompt you for code templates that match the pattern that you have started typing. So if you start typing always, it might prompt you with a set of the always type blocks that are available in the library. So select the one you like, hit enter, and it lays out that code block for you, oftentimes prompting you to put in some information, for example, the sensitivity list for an always block. Now, the plugin itself has a library of code templates, which are, of course, modifiable and extensible. So, if you don't like the way a particular one's laid out, you can change it. If there's a set of extensions that you'd like to add, you can certainly do that. This is actually something that was contributed by a user, and over time we've taken contributions of different code blocks that people like to lay out. Another place that we provide help that might actually seem a little bit counterintuitive is just code indenting. If you, like myself, really like to have your code laid out nicely, you might actually end up spending quite a bit of time keeping your code indented and laid out the way you like. The editing plugin here has an auto indenter, which in general, if you're just typing your content, will keep your code indented. And if you happen to cut and paste some code, it'll indent it for you. If you happen to get your code out of indent, you just select it and re-indent, and it'll keep everything up to date. I actually find myself using this quite heavily just to keep my code, up to date. And it saves quite a bit of time. Now, when it comes to the content of your SystemVerilog and creating new content, content completion is also a very helpful thing. So the SV Editor plugin, as you can probably guess, and is pretty common with other language plugins, does a full parse of the language source. And so it understands what modules are there, what classes are there, the elements of modules. And so there's a fairly rich set of information that the plugin has access to as you're typing content, so it can help you out. So for example, if you want to instantiate a module, the plugin knows what the port list is, it knows the type, it knows a bunch of information about that, so it can lay out an instantiation of the module for you with a port list. Now, the plugin will step you through filling in each and every one of the port maps. Generally, I just accept the default and go back and change it later, but you sort of have that option of getting a template of what you're laying out from the beginning that saves time, quite a bit of time. Because the tool is parsing the source code, it also, of course, understands what's inside elements. So this is UVM code where, because we've parsed the full SystemVerilog library, the tool understands the fields and the methods that are inside this, this phase variable. It knows the type, it knows what's in there, and so it can prompt me as I type, dot, what are the valid completions here? What methods could I access? And of course, because this is all documented with natural docs, it can also pop up a doc tag and tell me a little bit more about the element that it's completing here. So this works both in a class context as well as in a design, a module context. So if you need to do hierarchical references into your design hierarchy, this can help you do those dotted references. Now, in order to make SV Editor do all of this cool stuff, you do actually have to tell it a full list of your source files. You have to tell it the include paths, where the source is located, and the tool provides a variety of mechanisms to help make this more efficient. We provide some wizards just for sort of setting up an initial file list. We provide an editor for helping you edit and do completion in a file list. There are even some helper scripts if you have a simulation command or a compilation command to sort of extract out information from the command line arguments there. So this, again, can help you get started more quickly setting up that information needed by the editor. So hopefully by seeing the features, you have a little bit more appreciation for what using an integrated development environment can do to help you more productive as an engineer working on hardware descriptions. And by extension, those same benefits come for software type code as well, if you're writing Python, Perl, C++, what have you. So if you're interested in learning more, you can go to the DVKit website to download ready-built installers. You can go to the SV Editor website to get more information about the plugin. There's also, of course, the GitHub repository where all the source code is. We're looking to grow this. We're looking for new ways to make this simpler to set up and to sort of automate more of the setup steps. But if you're interested in using it, you're welcome to. Hopefully it will make your development process more productive and more enjoyable. So thank you very much.
Questions already? Yeah.
So you mentioned the Verilog parser.
Right.
Which one do you use?
It's a hand-coded recursive descent parser.
Okay, is it 2012? Which Verilog is that?
Which Verilog does it support? It's SystemVerilog 2012 mostly. And it supports subsets, so you can tell it, okay, I'm using Verilog, so don't consider the SystemVerilog keywords. So it's aware of essentially Verilog 2000, probably 2001, and SystemVerilog 2012.
And that's available as a Java package?
It is not extracted out as a Java package, though I've had a couple of users kind of do the extraction on their own for in-house tools.
Thank you.
Yep.
Hey there. Can you comment, are there any plans to support VHDL syntax?
Well, so what we have today is a very simple syntax coloring for VHDL.
Okay.
The task to do the full language parsing and indexing is a pretty sizable one. And as I'm mostly a Verilog and SystemVerilog developer, my motivation is kind of in that area. But definitely open to contributions, definitely open to people that want to help out.
Of course. And second comment, I find one of the features that's useful there's some similar functionality in a Sublime package. I think there's a SystemVerilog syntax highlighter.
That's correct. There are a couple of plugins for other editors.
One of the features I find useful in that is there's like a find driver of net thing. So if you can borrow that, I found that pretty helpful as well.
Thanks for the idea.
Thanks.
Hi, you mentioned that you accept contributions from users for like some of the auto completion.
Yes.
What languages can that be written in? Is it just Java?
It's just Java, yes.
Okay.
Yep.
Do we have any more questions?
Another one of those complicated features. Are you thinking about refactoring at all?
Short answer, yes. And yes, it is a very big feature.
All right. No more questions?
All right. Thank you very much. And I'll be around if anybody has questions after the fact. Thanks.